Hello everyone, and welcome to the Plotly and Cufflinks lecture where we actually show how we can program using these libraries to create interactive data visualizations. Let's go ahead and jump straight to a Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. I'm going to go ahead and do a couple of import and then some setup in order for this all to work. I'm going to say import pandas as PD, import numpy as NP, and then I'm going to go ahead and say from Plotly import underscore underscore version underscore underscore, and then I'm going to go ahead and say print version. And notice here I get 1.12.9. That's the current version I'm using. Everything we're going to be doing requires a version that's newer than 1.9. So here I'm already on 1.12. That means I'm good. If you have a version that's 1.8 or below, you'll need to upgrade Plotly. If you just installed Plotly, you should be totally fine on this. Next, I'm going to go ahead and say import Cufflinks as CF. And then finally, I'm going to import some libraries from plotly.offline. So Plotly, as a company, can support your online and can host your online data visualizations. But since we're going to be using this as an open source library and we're going to be using it offline, we'll need to do some imports from plotly.offline in order for that to work. I'm going to go ahead and import, download plotly underscore plotly.js, and you can just type D and then tab and it should autocomplete for you. I'm also going to say init, I'm just doing tab to autocomplete, init underscore notebook underscore mode, and then also plot and iplot. Run those. And then we're going to do a couple more commands. In order to have everything work in the notebook, just call init underscore notebook underscore mode and pass in connected equals true. And this is going to connect the JavaScript to your notebook, because Plotly essentially just connects pandas and Python to an interactive JavaScript library. And this is going to allow your notebook to access those visualizations. And then finally, we're going to say CF go offline as a method and close parentheses and run this. And this will allow us to use Cufflinks offline. All right, quite a few steps here to make sure everything works out, but hopefully you were able to follow those. Let's go ahead and now get some data and create it. I'm going to go ahead and say df is equal to pd.dataframe. I'm going to say np.random.randn, so normal distribution, and just pass in 100 by 4. So 100 rows, 4 columns, and I'm going to go ahead and say columns is equal to A, B, C, D as a string, dot split, and that way we get a list of the columns A, B, C, and D. And then if I check df just ahead of it, here I have my data frame. And I'm going to go ahead and create one more data frame called df2 pd.dataframe, and I'll use a dictionary for this. I'm going to say category is a column, and then the values are just going to be A, B, and C, or just any 3 strings you want. And then the other column is going to be values, and this is just going to be a string of some random values. Let's go ahead and just say 32, 43, and 50. And this is going to be used later for like a bar plot style. All right, now let's just go over how to use Cufflinks and iplot. It's actually extremely straightforward. If we take a look at our data frame, we have A, B, C, and D here. If I just call .plot off of this data frame, pandas will plot something with matplotlib. And if I actually want to see that plot, I can say matplotlib inline. And then if I run this again, let me go and just cut this and put it up top here. Whoops. There we go. And I'm going to come back down here and run this plot one more time. And here I see the line plot that pandas would have made automatically using matplotlib. I can just change this to iplot, and we're going to see almost a little bit of magic happen. That plot has now been converted to a Plotly interactive image, and here I can kind of scroll along and it'll actually tell me the values at that particular index point. So it's the exact same plot, it's a line plot, but now it's interactive I can zoom in, check out values. I can double click to zoom back out. And I also have tools here. I can save and edit the plot. I can download the plot as a PNG file. So if I just want a static image, I can pan. So if I wanted to, I could pan around. I could zoom in, zoom out, reset the axes, choose the hover, so closest on hover or compare data on hover. By default, you probably usually want to use compare data. And then I can even click on and off certain columns to view. So if I just want to view A and C, here I can view A and C. All right, hopefully you can already tell this is an extremely powerful tool because basically you just had to add one letter, iPlot, and now suddenly you look like an amazing interactive data visualization programmer when your secret was just adding iPlot and using Cufflinks and Plotly. All right, so that's the most basic example of Cufflinks and iPlot, and let's go ahead and explore now the various types of plots we can do. We can do many types like scatter, bar, box, ratio, heat maps, and more. So what we're going to do is just go through them and show you how to use iPlot to create other plot types that are not just line plots like this one. Let's start off by showing you how to do a scatter plot. I'm going to go ahead and say df.iplot. And then in order to switch the type of plot, you specify kind equals, and then for scatter, the string is scatter. And for scatter plot, you need to specify the x and y axes. You can go ahead and specify this by the column name. Let's go ahead and show a scatter of A column versus B column. And if we just run this, you'll see something funny pops up. You get something like this, and by default, Plotly is going to try to make a line to connect all these points. So what you have to do is specify mode and pass in the string markers, and then you'll actually get some markers here. And you can check out the markers, and then you can actually compare the A and B columns. You can zoom in and check out information on each of these points. All right, so that's how you can use a scatter plot using df.iplot. Pass in x and y arguments as the column names, specify kind is equal to scatter, and then pass in the mode equals markers. You can also do other things, such as pass in arguments for size. If you want these points to be bigger, you can go ahead and specify a larger size, and it'll go ahead and make those points larger. Now let's move on to a bar plot. For bar plots, you can say df.iplot, and say kind, pass in the string bar, and then you specify x, and we're going to go ahead and switch to df2 since that's a better fit for this plot. Just as a reminder, df2 has a categorical column and a numerical column, meaning for a bar plot, you want the x to be the categorical column. To make this obvious, I'm just going to say x is equal to the category column, and then y is going to be equal to the values column. And if we go ahead and check that out, now we have a bar plot where if I zoom out a little bit, I can see the value for each of these categories. So C is 50, B was 43, and A was 32. All right, and you can zoom in if you want, but that may not be too helpful for a particular bar plot. Let me go ahead and continue on. Now, as we know, your data is not always going to be conveniently placed, such as df2 with a category and values column, but what you can do is call group by or an aggregate function on your data to actually get it into some sort of form where it makes sense to use a bar plot using iplot. Let me go ahead and show you what I mean by that. If we take a look at our original df, we can see that we have A, B, C, and D. Now we wouldn't be able to call bar plot off of this, otherwise we'll just get a bunch of bars. And I'll show you what I mean by that. If we just said kind is equal bar, you'll get a bunch of bars for every single data point. And that's not exactly what you want. You would need to do some sort of aggregate function on top of this. For instance, let's say you wanted to count the instances for each column. And here we have a bar plot for each instance, which in this case is just 100 since they're all evenly distributed. But you can do other things such as take the sum of each column, and now we have a bar plot showing the sum of each column. All right, pretty interesting stuff, but keep in mind that this bar plot with iplot becomes really powerful when you call some sort of aggregate function or a group by function on your data frame. More likely your data frame is not going to be in this kind of nice formatting. Okay, that's a bar plot. Let's discuss box plots. Now box plots, your data can be something that looks like this. Box plots will automatically do that sort of aggregation for the distribution. And you just do this by specifying kind is equal to box. And here it will automatically make a box plot for each of the columns. And you can turn columns off or on either by passing them here with df or just by switching them on and off here with plotly. For instance, if I only wanted to see A and C, I can just click on A and C. And I can click on B and D as well and see what I want. And it will give you information on the quartiles here for the box, which is quite convenient. Now let's talk about a 3D surface plot. In order to really talk about the 3D surface plot, I'm going to make a new data frame. We'll say df3 is equal to pd.dataframe, and we'll go ahead and say x is a column, and we'll just say 1, 2, 3, 4, 5. We'll specify y as a column with the values 10, 20, 30, 20, 10, so it goes up and then down. And then we'll specify z is a column, and let's go ahead and specify this to be 500, 400, 300, 200, 100. Okay, so I have my data frame. Let's take a look at it. And this is basically 3 dimensions of values, or 3 variables. We can use a surface plot if we wanted to create a 3-dimensional surface plot of these 3 variables. You can say df3.iplot and specify the kind to be a surface plot. And this will create a surface plot of what we have here. So you can see we have a surface plot. Now let me show you another example of a surface plot by kind of changing these values around. Instead of saying 100 through 500, I'm going to say 5, 4, 3, 2, 1. And now let's plot this, and we can see now we have kind of this peak outline. And we can actually change the color scales here in case we don't like this rainbow color scale. We can say something like color scale and say RD for red, yellow for white, YL for yellow, and BU for blue. And you can check the Plotly documentation for all the color scale codes. They don't exactly match up with the matplotlib color maps, so keep that in mind. And here we have a really nice surface plot directly made off our data frame, and we can rotate it and play around with it in order to get all the information out of it. All right, that was a 3D surface, and finally I'm going to talk about a couple more plots. A very basic one that you'll probably find yourself doing is a histogram. You can say df, call a single column, and then say iplot, kind is equal to hist, and you will get a histogram. And you can actually specify the number of bins with another argument. For example, if you want 25 bins, you can specify that and get more bins. Let me go ahead and make this more obvious by specifying a lot of bins. Okay, and here we have more bins. Now there weren't that many data points, so keep that in mind. If you go ahead and pass in the entire data frame, let's just call it df.iplot kind equals hist, you will get a overlapping histogram of all the columns, meaning you can compare the histograms of columns, and you can turn them on and off to compare them to each other. Now these are randomly normally distributed, so they're kind of overlapping each other, which makes sense given the way we created this. But you can turn them off and on to view histograms as you please for all the columns in the data frame. So it's up to you whether you want to just pass in one column or pass in the whole data frame and then switch them on and off. Next one I want to show you is a spread. Spread type visualizations are used a lot for stock data to compare two stocks. I'm going to go ahead and just do them with our random values here. Later on in the financial data capstone project, we'll actually see some more technical analysis plots. But if I just say these two columns, A and B, off my data frame, I can say iplot kind is equal to spread, and we'll get a plot and then a subplot. I'll get my line plot, which shows them against each other, and then I will get my spread plot, which shows the spread of them against each other. So for instance, if we go ahead and zoom in here on the 20, we can zoom in here, let's see where it corresponds to 20. We'll notice the spread is negative 0.38 between them, and here we can verify that as a result. So negative 0.38 minus 0.18 will take us to 0.56, about there. So you can go ahead and compare these results, and this is essentially really useful for stock data to see the spread between two stocks. We have two more plot types to show you. The next one is a bubble plot, and a bubble plot is very similar to a scatter plot, except that it will change size of the points based off of another variable. So if I say kind is equal to bubble, I'll specify x and y just like I did for a scatter plot. And then I will specify the size of the bubbles based off another column. Let's go ahead and just choose C. And here now I have a scatter plot, except the size of the points is based off another column value. And you see these kind of plots a lot for things like world GDP in comparison to population and maybe happiness factor, etc. So these are quite common plots, especially for things like United Nations reports. All right, so that's the bubble plot. And then finally, we'll get to the scatter matrix. The scatter matrix plot is essentially very similar to Seaborn's pair plot. It just creates a scatter matrix of all the columns it can. So you say df.scatter_matrix. You may need to make sure all your columns are numerical in order for this to work, but it's just a scatter matrix, and you can kind of zoom in on each plot individually. Keep in mind, if you have a lot of points here, this will take a while to load and may be very slow as far as zooming in and out. So use this with care on very large data sets, otherwise you may crash your Python kernel. Okay, that's it for the basic plot types that we're going to go over in this lecture. If you want more information and some more details about the documentation, I would recommend actually going to the GitHub page, and that's available just by searching GitHub and Cufflinks. It should take you to this page. It's hosted by this user Santos Jorge /Cufflinks, and I've contributed to it as you've seen before. And you can check out right here these Cufflinks tutorial links where you have a chart gallery. It'll let you know what colors are available, offline, pandas like, and plotly. There's a lot of really good information here. So for instance, if we go ahead and say pandas like, we've already gone over quite a bit of this information, but there's actually some more basic plotting methods such as bar plots, histograms with maybe stacked histograms, some more detail, grouping values on box plots, area plots, which we didn't go over, but it's basically just saying kind is equal to area, and there's some more information. Now we've actually done a lot of this already, but if you want some more details, you can always reference this documentation page, which is pretty nice. Okay, lastly, I just wanted to mention that there's some technical analysis capabilities with Cufflinks that are built in. They're still under beta. They're not fully released, but you can check them out in the technical analysis section of this library. You can find out more about these technical analysis plots by clicking here on Cufflinks folder and then checking out ta.py. And this is the technical analysis.py file. Again, this is kind of advanced stuff, and it specifically is dedicated to financial analysis. So if you're not interested in financial analysis at all, don't worry about this, but you can check out a couple of the functions here and a couple of the types you can do. It allows you to do things such as moving averages or correlation between plots or stocks, etc. We'll explore some of these plot types later on in an optional section of the Financial Data Capstone project. But if you're not interested in this sort of stuff, don't worry about it. I just wanted you to be aware that it's there for you in case you are interested in financial analysis and creating interactive plots for that. Okay, thanks everyone. I hope you enjoyed learning about Plotly and Cufflinks. It's a really powerful tool, and the good news is you don't have to adjust your knowledge that much for it. You essentially just add an I and remember what kind of plot you want to pass. Okay, thanks everyone, and I'll see you at the next lecture.